Hello everyone, good evening and welcome to the show. I really do apologize for today. There's been a slight delay. I've been a bit occupied the entire day. It's just dealing with a lot of things. Life catches up to you, so hopefully you can pardon me this mistake. Anyways, we're here today. I got here eventually and been 6 minutes late. Now that's a lot of time. We could have actually done a solid 2 questions within those 6 minutes. But not to worry, we're going to try and catch up. We're still going to have some breaks because keeping breaks is very important and we cannot miss out on that. But anyways, so yeah, I'm just going to give this a quick start. I just need to quickly share this link onto where it's supposed to be and then we can get a head start. Paste. And we're looking at session 3, I believe. Session 3. Okay, cool. Save. Posted the video, amazing, the channel's live. Simply Learning Live, Core Mathematics. Okay, back to work. So, last time that we were here, we talked about basic sort of algebraic equations. We did some quadratics. We worked out one question that was in a worded format. So they basically put it in a worded format. We did some substitution, simultaneous equations. Simultaneous equations. We also covered, let's see where we picked up from. So that was session 2, I believe. Yeah, so we simplified some expressions. We then went on to evaluate simplification of more expressions. We talked about surds and how their rules, the rules of indices get applied into that sort of realm. We went on, did some more questions. We did roughly 5 questions of each. We did some quadratic equations, how to solve them using various methods. Completing the square, and we even derived the quadratic equation right at the end, almost towards the end of this session. Deriving the quadratic equation is right there. We went on to do simultaneous equations, and that's where we sort of parted out. And we kind of said that when we come in next time, we're going to try and do some equalities and inequalities based on the learning schedule that has been put forward by the series. So the series is basically covers algebra basics. It covers indices and surds. It covers quadratic equations, equalities and inequalities, algebraic division, fractions and partial fractions within the topic of algebra. So we're still in the basics, and what we're going to be doing today is we're going to be doing some simultaneous equations. We're going to carry on doing simultaneous equations, probably solve it using substitution, etc. We're then going to move on to equalities and inequalities, and yeah, we'll try to sort of visualize that as well. Probably not visualize it because that goes into coordinate geometry, but we'll try to work it out using our wits basically. So we'll take it from there onwards and we'll see where it goes from there. Now I just want to double check as well because we're going to be doing some more algebra. I need to check the other books, but in the meantime what I'm going to do is we'll just sort of start off with the series. And when I'm taking my breaks, I will regroup with my thoughts. I really do apologize. I've been a bit sort of occupied of late. So these sessions have started to become a lot of me talking, which really should not be. We're literally just here to solve equations, try to see how to solve equations, etc., etc. Anyways, let's see how it goes along. Okay, so let's do some linear equalities and inequalities. Now, of course, for those of you that have learned about this stuff, when we talk about equalities and inequalities, so we're just going to do some finding the set of values. So find the set of values which satisfy the following expressions. And seriously, pardon my handwriting. Excuse me. I'm having a bit of dry cough. Okay, find the set of values which satisfy the following expressions. So, let's start off with the first one. Let's do a basic one, and we're going to do an inequality for this one. So, let's say it's 2x minus 3 is less than 5. So, we need to find values for the value x. So we need to find the set of values which satisfy the following expressions. So we need to sort of keep in mind x essentially for this entire equation, because this is a linear equation and there's no second variable. But it is possible to represent one variable as an expression of certain mathematical operations formed on a second variable. So for example, if there was a y in the equation, we'll probably cover that in the next couple of questions, but for now we just have one variable in the equation, so we'll just stick to that. So in this case, 2x is less than 5 plus 3. We can literally just treat it as an equal to sign, unless of course you want to change the operations. So if you multiply everything by minus 1, what happens is we get minus 2x, which then implies, I'm just doing this for sort of namesake anyways, but we're not going to be sort of considering that in any manner or form. Let's see, which also implies that minus 2x is greater than minus 5 minus 3. You get me? So, yeah, essentially you could have written it however you want, but yeah, this is definitely a way to do it. Okay, but we'll not just carry on. We'll just carry on with the standard equation. So x is less than, what was that, 8 divided by 2? 8 divided by 2, which implies x is less than 4. And that's the final. Now, if we were to carry on with the negative equation and follow that, what that would basically tell us is, which would imply is, it will basically be the same thing. So it will be x, so it'll be minus x, minus x is greater than, minus x is greater than minus 8 divided by 2. And I would just sort of cross it out, and that would give us minus x is greater than minus 4. Yeah, I do believe that's right, because then, yeah, so minus x is greater than minus 4. Yeah, that sounds about right, yeah. So, yeah, technically both of them are right, but we're looking to sort of stay in the positive realm. So, of course, this is the correct answer, where x is less than 4, rather than minus x is greater than minus 4. I'm going to have to double check this, but as far as I am aware, this is definitely right as well. So it says when you multiply or divide an inequality by a negative number, you need to change the inequality sign to its opposite, which definitely does make sense. So if I multiply by minus 2, yeah, sounds about right. So yeah, this definitely also makes sense. And then when you start to visualize this later on, when we start talking about coordinate geometry, we'll probably do some inequalities as well. I need to add inequalities into the coordinate geometry section, but yeah, we'll do that, and yeah, we'll probably find it over there. Okay, how to visualize it. But yeah, in this case, both answers, they can be considered. That's only if you sort of multiply by minus 1. I don't understand why somebody would do that, but yeah, we can do that. This is basically the negative term of this. So yeah, no, this definitely does make sense now. Yeah. Okay, yeah, cool. All right, number 2. I'm sorry, it's just working out in my head, but then, you have to sort of work it out later on for it to make sense. This is going to be covered in the lecture series, like all of this stuff. So yeah, it's best to keep a watch out for that one as well. All right, let's do another question. We are going to consider what are we going to consider? We're going to consider a new question where it says let's do this one this time. So we have 15 minus x is greater than 4. So what we can do is we can either, so again, there's two ways that we can do it. We'll try doing it both ways, and you can see how we relatively end up with the same answer. So if we take it as implies, we end up with 15 minus 4 is greater than x. Okay? Yeah, so x is less than, which implies x is less than 15 minus 4, which gives you x is less than 15 minus 4. What does that equal to? 11? Having a blank moment, sorry. Okay, so we ended up with that. Let's try a different way. See if we can end up with the same answer with the the multiplication side of things and everything. And of course, this also stands true that if you were to do sort of if you were to multiply the whole thing by a negative, yeah, when you multiply the whole thing by a negative, then yeah, you just basically sort of flip the inequality sign. So then the former becomes the prime becomes the former. Right. So let's do a consideration. Right. So if we say minus x is greater than 4 minus 15, and that would imply minus x is greater than minus 11. So as you can see, we'll basically end up with roughly the exact same answer, as you can see over there. So I'm just going to have to put you guys on hold. I'm going to be back in the next 10 minutes. Just give me another 5 minutes. Sorry, I will get back. Don't call me between 6 and 9 on Tuesday. Do not call. Block all the phones. Okay, hello everyone. Sorry about that. My apologies. We're back. Yeah, we're just gonna carry on from where we left off. So we basically ended up with the same answers, as you can see. So we ended up with minus x is greater than minus 11, or x is less than 11. Now, I can understand how that can be a little bit confusing, but I presume that eventually will be the exact same answer. I don't know how that's the exact same answer, but yeah, we can apparently end up with two separate answers. But always try to stay within the positive realm, because yeah, that's what we want. We want the positive number of the variable. We don't want the negative one. I mean, of course, the negative one you can't find out, but at the end of the day, it's the positive one that everyone cares about. So don't worry about the negative one. And also bear in mind, there's going to be a lot of people who are going to try and sort of mess up your workshop time. That's okay. Take some time. Go explain to them whatever you need to do. Go handle your business. Come back to it. And yeah, just stay positive as it is. Don't let anyone's visions or explanations try to cloud your own judgment or your thinking. Okay, let's do another one. I'm going to do a little bit of a different one this time. And it's different... equator. I don't know what they call it. They call arithmetic operators. Yeah. Alright. 2x minus 3 whole is greater than or equal to 0. So roughly the same thing goes on over here. I presume that you can probably figure out what happens here. So if we say that implies, again, you can find out either negative or the positive, but then again, I don't want you guys to focus on the negative set of numbers. What you want to do is you want to find the positive set of numbers. It's technically not the same answer, if that makes sense, because we have x, which is what we're concerned with, because that's a positive number. But you don't want to worry about negative x, because negative x is a completely different requirement. So you don't have to worry about negative x. You find out positive x, and then of course later on you can work out negative x based on what is positive, if you need to use negative x. But technically the basic answer is just a positive. So you're not ending up with two separate answers. You're basically ending up with one answer which is definite, that okay, x is so and so, whatever it is. So say for example in this equation we have sort of 0 divided by 2 is just going to be nothing. So we end up with x minus 3 is greater than or equal to 0, and which then implies that x is greater than or equal to greater than and equal to 3, because the minus 3 goes over there, so you get plus 3. Cool. And that would be the final answer, which would also imply that minus x, I'm just going to write that in sort of a separate thing, which would then imply that minus x is less than or equal to minus 3. So yes, both of these are exactly true, but of course, because you have one of them, you can also work out the other one of them. Okay, let's move on to the next one. Let's see. Let's do a slight bit of a quadratic equation over here. I want to see if I can do that. So we have 2x minus 5, and that's in brackets, of course. So 2 multiplied by x minus 5 in a whole is greater than 3 and then 4 minus x in brackets. 4 minus x in brackets. Okay, cool. Right, so now what we're going to do is we are going to multiply the... No, we can't do that. It's strange. So, okay, you know what? Let's just multiply out all the all the terms and then see what we end up with. I don't think this is a quadratic, just to confirm. No, I don't think it is. So anyways, implies 2x minus 10 is greater than or equal to 12 minus 3x. And that would imply 3x goes that side, 10 goes that side. So you end up with 3x plus 2x is greater than or equal to 12 plus 10. And you would end up with, was that 22? 22 and 3 plus 2 is 5. Yep. So that would imply 22x, no, sorry, apologies, 5x is greater than or equal to 22, which implies x is greater than or equal to 22 divided by 5. Yeah, so that would be the final answer for that one. Let's try another one. This time I'm going to try and pick out an actual quadratic. I think I just looked at it and I thought it was two quadratics, but it's not. So we're going to try and pick out a quadratic. Yep. Okay, let's do this one. So you have x minus 4 is greater than or equal to x squared plus 2. Right, and that implies x squared minus 4x is greater than or equal to right, let's just bring the x squared on that side as well. So we get minus x squared plus minus 2 is greater than or equal to 0. Yep. And we write further. We then say, I'm going to try to sort of compact everything down now, so because we're starting to work on heavier equations. So then we say the x squared cancels out. How interesting. That's not fun at all. Okay, so the x squared definitely cancels out. Wow, this is definitely not a quadratic. All right, x squared cancels out. You end up with a minus 4x and a minus 2. We're just going to put the 2 on the other side. I don't know why did I bring the 2 on this side. It's greater than or equal to 2. And we are going to have to swap them both around. So there's both ways you can do it. You can either sort of switch the numbers around and keep the signal, the sign the same, or you could basically multiply the whole thing by minus 1. So you can write it as this. So which would imply that 4x is less than or equal to 2. And that implies that x is less than or equal to 2 over 4, which is equal to 1 over 2. Yeah, definitely. Okay, that makes sense. Right, so you can just leave that as the answer. So that's the answer. So you would technically write as x is less than or equal to a half. That's what you'd probably write it as. 5, 6. Let's do some more of these, because these are actually fun to do. Probably, possibly, maybe not. Let's find out. Yeah, let's do a couple more of these, and then we're gonna move on to doing quadratics next. So we have 12x minus 3, x minus 3 is less than 45. Which implies 12x minus 3x plus 9 is less than 45, which would then imply that 9x is less than 45 minus 9. 45 minus 9 is 36. They're both still multiples of 9. So that would imply that x is less than 36 divided by 9, which would give you x is less than 3, 4. 1, 2, 3, 4. 4. Right. As a final answer. So another one, 7. So this one, 5x plus 6 is less than or equal to minus 12 minus x. So that implies 5x plus x is less than equal to minus 12 minus 6. Okay, and that implies 5x plus x is 6x. 6x is less than or equal to minus 18, which then implies x is less than or equal to minus 18 divided by 6, which would imply that x is less than or equal to minus 3. That should be final. Let us try doing another one. 8, 7, 8. Right, so we're going to do 8 now. Let's say we do this one. So 1 plus 1, 1. 1 plus 1, 1. Brackets 2 minus x is less than 10. X minus 4. Okay. Should imply 1 plus 22 minus 11 x is less than 10x minus 40. Swap things around, which would imply 23 plus 40 is less than 10x plus 11x, which then implies 23 plus 40 is 63. 63 is less than 21x. So that implies, now remember, if you're you can say it in your wordings as well, 63 is less than, so 21x is greater than 63. So you can write down 21x is greater than 63. And then you say further, x is greater than 63 divided by 21, which implies x is greater than x is greater than 3. How many problems today we're having? Like, things just coming straight forward, head on. I don't understand. I'm gonna try and face them, see what happens. I don't see any problems going on now. Yeah, we'll see how it works out. Maybe it's actually worked out for better. We'll try and see if this actually works. Is it gonna work? Is it gonna work? Right, so there you go. That works. And is this going to work? Yes, this works as well. Yeah, whatever. Plug that in. Because I do am be looking for a charging point. Okay, there you go. Seems to be charging fine now. And finally, I'm just going to check on the live stream if it has updated. Okay, yeah, it has. So everything's looking good. Let's carry on. We're going to do another 2 questions of solving equalities and inequalities, and then we'll move on. We're going to be doing, I believe from the next book, there's not a lot of things. Alright, let's do this. Find the set of values of x for which 15 minus x, this is technically how all questions should have been worded, where you have, oh, these are simultaneous equations. Okay, no, let's do that. This is better. Okay, find the set of values of x where, alright, let's check it out, where 15 minus x is less than 2 brackets 11 minus x, and 5 times 3x minus 1 is greater than 12x plus 19. So they want us to do this, and I believe the easiest way to do that is so the easiest way to do this is to deal with easiest way to deal with this is sort of solving them one at a time. So let's name them A and B and B. And now let's solve them. So let's just do A first. We have 15x, 15 minus x, my apologies, is less than 2 times 11 minus x, which implies 15 minus x is less than 22 minus 2x, which then implies 2x minus x is less than 22 minus 15. Yep. And which would then imply that x is less than 22 minus 15 is 12 minus 5, 12 minus 5, 7? Do you believe 7? Okay, and I believe that's like answer to part A, so that's number 1. And now part B says 5 3x minus 1 is greater than 12x plus 19. Okay, so that's it, which then implies 15x minus 5 is greater than 12x plus 19, which then implies 15x minus 12x, which is 3x, is greater than 19 plus 5, which implies 3x, like I said, is greater than 19 plus 5, gives you 24, greater than 24, which implies x is greater than 24 divided by 3, which implies x is greater than 24 divided by 3 is 8. 8, yep, 8. Now that's the second part. So when you bring them both together, because x is less than 7, x is greater than 8. So you can write it as, which implies x is less than 7 and x is greater than 8. So you can write it like that. So you just write x in the middle and then you say x is less than 7, sounds about right, and x is greater than 8. So you have x is greater than 8. It's always beneficial to sort of say things out loud, where, of course, it makes it easier to comprehend what's happening. So that's 9. Let's do another one. 10. Now, I was literally doing simultaneous equations, essentially. Because you have two separate equations, and you're trying to say, okay, which number can I put in this variable to satisfy both terms, both expressions, sorry. So, yeah, it's literally just doing that. Now, I believe based on what I have seen so far, it does seem like we're going to require more sessions to actually complete the topics. So what I'm going to do is, starting next week, I'm going to maybe add another session onto all of these workshops, just so that there's more time to spend on equations and other things that we work on. But essentially, it all depends on how it goes. And hopefully next week when I come back, I'm going to have a bit of a better idea on how to manage all of these different, how to manage all of this, all the topics in the various different formats. So hopefully next week is going to be much easier. But anyways, for now, let's just carry on doing some equations. It's a bit easy. It's good to be doing. 3x plus 8. So again, we're going to satisfy the same equation. So we're trying to find the set of values for x where a and b exist in the same realm. So they exist in the same dimension, or realm, however you want to call it. So you have a, which stands as 3x plus 8, is less than or equal to 20. So we try to solve this first, so which would imply 3x is less than or equal to 20 minus 8, which then implies x is less than or equal to 12 divided by 3, which implies x is less than or equal to 12 divided by 3 is 4. So that's one part of the equation. Second part of the equation is b, which is 2 parts 3x minus 7, not subscript 7, which is greater than or equal to x plus 6. Write that down, so that ends up with 6x minus 14 is greater than or equal to x plus 6. Swap things around, and we end up with 6x minus x is greater than or equal to 14 plus 6. So that ends up with 5x is greater than or equal to 20. Yep. That implies x is greater than or equal to 20 divided by 5, which then implies x is greater than or equal to 4. That's the second part of the equation. Interesting. So this is an interesting one where we have sort of where we have sort of x is less than or equal to 4, and we also have x is greater than or equal to 4. So in this specific case, I'm probably thinking that if we write this down, it will make a bit more sense. So if we say the final answer is x is less than or equal to 4 and is greater than or equal to 4 again. So which implies x is everything. Well, that's not actually true. X can be anything. Anywhere. It can be any number within the real numbers. Hopefully not an imaginary number. Yeah, it's weird. Maybe, I don't know. It can be any number. Any rational number, should I say. Anyways, I'm just going to sort of cut this out because, yeah, I don't want to sort of complicate things. But yeah, if you just leave it as this, that would make more sense. So x is less than or equal to 4 and greater than or equal to 4. Okay, we're going to try and moving on and doing some quadratics within the simultaneous equations and equalities and inequalities realm, and we'll see where we go from there. Okay, so it says find the set of values right, so we already know the question. I'm not going to write it out, but we're going to do sort of quadratic inequalities. I'm just going to write that down. Quadratic inequalities, or equalities, whatever you want to call it. Let's do the first one. You have 7 plus 13x minus 2x squared is greater than 0. And that implies we want to try and get the x as being a positive. So that's exactly what we're going to do. So we're going to end up with 2x squared minus 13x. And now remember, because we multiply the whole thing by a negative number to get all of these numbers, and you get a minus 7. This sign basically flips. If you're writing it within the same dimension, sort of ground, sort of same format, same sequence. If you're writing in the same sequence, then yes. Same side of the equation as well. So yeah, then it's less than 0. But you would still say it in the same way. So this equation will be less than 0 if it was like that. But if you multiply everything by a negative number, then it will be greater than 0. Anyways, moving on. So, which would then imply we have, so something that has to multiply to give me minus 14, add to give me minus 13. It's definitely minus 14 and plus 1. So we have 2x squared minus 14x plus x minus 7. I think that's literally what it would be. Is less than 0. And that would imply 2x goes on the outside. And you have x minus 7 as a common factor between the first two terms. And then you have a plus 1 as a common factor. And x minus 7, which has been left out, is less than 0. Which then implies x, where is it? Which implies x is, where's x? Let's write it down. 2x plus 1 is the common factor, and x minus 7 is also another common factor, is less than 0. Now in this case, what you do is you basically say, okay, how am I going to get x to be less than 0? So what you can do is you can say, okay, well, you know how to get x is equal to 0. You say, okay, if x is 7, you're going to get 0. And if x is 1.5, no, sorry, not 1.5. If x is a half minus a half, then you're also going to get 0. And what you want to do is you want to say, okay, I'm going to write this down. So if I just write down, so x, for solving this quadratic equation, so x can either be equal to 7 or minus a half. Now what I want to do is I want to see what happens if x is more than 7. Because we're trying to find out the values for x, which would give us 0, or something less than 0. So if I get a negative number, if I put in 8 into there, then that means x has to be, and if I still get something less than 0, if I put in 8, then yeah, x has to be less than 7 and greater than the other one. But yeah, let's see how it goes. So if I put in 8 over here, so if I get 8, so I get 8 minus 7, which is 1. And I get 2 times 8, which is 16, plus 1 is 17. 2 times 8, 16, plus 1, 17. 17 multiplied by 1 is definitely not less than 0. So which means anything less than 7, so if I put in 6, so if I get a 6 minus 7 is a minus 1. And if I get a 2 times 6, 12, plus 1, 13. 13 times minus 1 is minus 13. So minus 13 is definitely less than 0. So in that case, what we say is x is less than 7. To give this equation, basically. Yeah, so x can be less than 7. And if x is less than 7, then of course the other side, how it works. I mean, you can do the same thing over here as well. So if you substitute in a 1, you can see what kind of, if you substitute in a 0, sorry, yeah, because 0 would be a greater number, yeah. So if you substitute in a 0, so you get 0 plus 1 and 0 minus 7, and then 1 multiplied by minus 7 is less than 0. So which means anything greater than minus a half also gives you less than 0. So you can also say, okay, x has to be greater than minus a half, and to give right. So that basically implies x is less than 7 and greater than minus a half. Excuse me. So this is how you can work, and you can actually find out quadratic inequalities and find out the values of x in terms of quadratic inequalities. Let's do the next one. I'm starting to feel a bit sleepy now. Don't know why. Okay, so it's been roughly an hour. I'm going to take a 5, maybe 10-minute break. I'm going to get back to you guys at 19:05 by the clock. Share on the screen. Okay, hello everyone. Sorry about that. Gonna be back about 1 minute early. That's perfectly fine. Not a problem. Let's start by working out some random exercises. So, let's see. What were we working on? We were working on quadratic inequalities. Let's do a couple more of these, and then we'll see where it goes from there. So, quadratic inequalities. Let's see. Find the set of values of x where, so I'm just going to write 2. We have 11 is less than x squared plus 10. So it would imply x squared is greater than 11 minus 10. Now you can see you can write that because, you know what, it's just a bit easier to do this. So x squared plus 10 is greater than 11. Do it in steps, whatever. That's perfectly fine. Which then implies x squared is greater than 11 minus 10. Which then implies x is greater than 1. Because the square root of 1 is 1. So that would be the final answer for that one. Let's take another question into mind. This time it's going to be a simultaneous equation for x squared. So we have x squared minus x minus 12 is greater than 0. And before I carry on with this, I also need to specify that, let's just write it over there. I'm just going to write a and b are within the same realm or domain or dimension, whatever you want to call it. And this is A. So we need to find the value for x, which multiplies to give us minus 12 and adds to give you minus x. I'm possibly thinking it's minus 4 and minus 4 and plus 3. So we end up with x squared minus 4x plus 3x minus 12 is greater than 0. And that would imply x and x minus 4, and then you have plus 3, and you have x minus 4 on the other side is greater than 0, which would then imply x minus 4 is the common factor between x plus 3. And that's greater than 0. So in this case, of course, we're going to figure out the values of x in terms of this. So x is equal to 4 and minus 3. Yep. To give you somewhere between 0. Now if anything was greater than 4, so let's put it up as 5. You get 5 minus 4, and 5 plus 3 is going to be giving you greater than 0. So in this case, you would say that yes, okay, what do you call it? You would say, okay, so if you go 5 minus 4 is 1, and it says 5 plus 3 is 8, so 1 times 8 is greater than 0. So which means x is greater than 4 to give you greater than 0. And if it was, let's say if it was less than minus 3, or yeah, if it was greater than minus 3, before we sort of finalize this equation over here, you also need to check if it's less than. So what if x was 3? What happens then? So you get 3 minus 4 gives you a negative, and then 3 plus 3 is 6. So 6 minus 1 is not greater than 0. It's actually less than 0, because 6 times minus 1 is minus 6. So that's less than 0. So therefore, x has to be greater than 4. Similarly, if you get x, if x is right, so yeah, you basically get the idea. So if x cannot be less than 4, then it has to be greater than minus 3. Usually, yeah, because it would say if x is 4, then you get a 0, and then if x is minus 3, you get a 0, which means if x is positive above 4 and below 4 it's negative, that means below minus 3 it'll be negative. So if I do minus 2, and we try to see what we get over here, so we get minus 2, minus 4, and then you get minus 2 plus 3 is, minus 2 plus 3 is minus 1, and minus 2 minus 4 gives you minus 6, and minus 6 minus 1 multiplied by minus 1 gives you 6, and 6 is greater than 0. So that would also imply x is less than minus 3. So minus 4 minus 5. Am I getting this right? So if I get a minus 4 plus 3, yeah. Oh no, so if it was a minus 2 plus 3 will give you 1. Sorry, yeah, so that would give you positive, right? So yeah, but if it was minus 4 minus 4 gives you minus 8, and minus 4 plus 3 gives you minus 1. Yeah, so minus 8 minus 1 gives you 8. 8 is definitely greater than 0. Right, so x is less than minus 3. Okay, so we've finalized these two things over here. We move on to the next half of the equation, which is b, and that states, second half of the equation states 3x plus 17 is greater than 2. So 3x plus 17 is greater than 2. So that would imply 3x is greater than 2 minus 17. x is greater than 2 minus 17 and minus 15. So minus 15 divided by 3, which would give you minus 5. So x is greater than minus 5. Okay, so in this case, what just happened there? Right, so in this case, what would happen is we basically write out all the equations. So we got this, we got that, we got both parts of the equations, and we want to satisfy both at the same time. It's not an or, so one of them can be satisfied, then it's okay. No, we need to satisfy both of them. So which numbers of x are going to give us numbers which is going to satisfy both of these equations? So if you write them down, so we have x, first of all, is greater than 4. And then we have x is greater than minus 5. So that means anything above minus 5 is okay. And we also have x is less than minus 3. So what we first sort of find out over here is that anything above 4 is going to be okay. Anything below 3 minus 3 is also going to be okay. But in this we learn, and anything between 4 and minus 3 is not going to be okay. So what we learn is that x can be greater than minus 5, but is not equal to anything between 4 and minus 3. So the way you can write that as is you have x is x is, I don't think you've done sort of not greater than or equal to. Yeah, I don't think that would be the case. Yeah, so I think the way that you would do that is you would just probably say x is greater than minus 5. Less than minus 3. So x is greater than minus 5 and less than minus 3. And x is also greater than 4. So 4 is less than x. Yeah. So I believe this would be satisfactory. Whoa. I believe that would be a satisfactory answer, but if you were to write it like that, I think that would be okay. Let me try to just double check if that is indeed the right answer. So we're looking at 3e. We're just going to ruffle through the pages a little bit to get the answer of 3e. No, we're not looking at coordinate geometry. 3e. Wow, 3e, 3e. Yeah, so we've got it absolutely, that's exactly how you would write that. You would say x is greater than minus 5 and less than minus 3. And you would also say x is then greater than 4. So, yeah, you can either write it as that. You can definitely write it as that. I don't think there's any other specific way to write it, because you have two separate sort of, you have like numbers in between where it's not possible for x to have that answer to satisfy both of these equations. So that's why you can just leave it as that. Okay, let's do another one. This time we're going to do a quadratic. 3, 4. Yeah, we're going to do this was a quadratic. Yeah, it was. 100%. Okay. That was only 3? Are you sure? I'm pretty sure it was... No, it was only 3. Okay, let's do a basic one again, and then we'll wrap it up with a complex one. Okay. Okay. So let's do a basic one. We have x squared minus 9. I like this one. This one's going to be good. Is greater than 0. Now remember, this works out to be the difference of squares, I believe, because x squared minus 3x plus 3x minus 9 is greater than 0. So we can write this as x squared minus 3x plus 3x minus 9 is less than 0. And then we say x minus 3 let's do that properly. So we have x minus 3 plus 3x minus 3 is less than 0, which then implies x minus 3 multiplied by x plus 3 is less than 0. Now if we try to find the roots, if you're trying to find what would give you 0, you would know that x can either be equal to minus 3 or it can be equal to 3. But what if it was, we need to find where it's less than 0. So if x is 4, you get 4 minus 3 and 4 plus 3. So you get 7 multiplied by 1 is not less than 0. So which means x has to be less than 3. And if you get minus 4, so if I put in minus 4, we get a minus 4 minus 3 gives you minus 7, and then minus 4 plus 3 gives you, minus 4 plus 3 gives you minus 1. So minus 7 multiplied by minus 1 is not less than 0 because that's just 7. So which would then imply that x has to be greater than minus 3. So there you have it. So that would imply x. So that would imply x, let's put x in the middle, is greater than minus 3 and is less than 3. And that's your final answer there. Okay, so now for the last one, we're actually going to do a more complicated question. And we're going to see how this turns out. I'm doing this at the same time as you guys, so yeah, let's see how this works. So the question I'm going to write in yellow. I'll write it in yellow, yeah. So it says find the range of values of P for which the roots of the equation px squared plus px minus 2 equals 0 are real roots. So now what it's basically telling us to do is we're trying to find, and remember when you talk about real roots in quadratics, you're basically looking for real numbers. So basically, you know, the quadratic equation has to equate to a real number, and the only way that you can get a real number is if you don't have an imaginary number. And an imaginary number is created when you have the negative of a square root. So if you have a negative x and if you square root that, that is not real. You know, that's not a real number, that's an imaginary number. Sorry, my apologies. That is an imaginary number, and you actually write it as an I, and you learn about that later on, how to use all of this stuff. It's pretty simple. That's pretty much, I suppose that's pretty much it. But for now, we don't have to worry about that. We just need to worry about something that gives you the real roots. So we write this into the form again, where you have ax squared. So remember the basic of, when you solve the quadratic equation, or the quadratic equation is written like this. So you have ax squared plus bx plus c is equal to minus b plus or minus square root of b squared minus 4ac. Okay, and then divide that by 2a. So in this case, where a is equal to b, so a and b are both the same, right? That's what you need to bear in mind, which is equal to p. So if you just write that down, we can figure that one out. And in this case, c is equal to minus 2. Yeah, absolutely. So if we substitute all of this in, which is literally just substituting all of that into this equation, and we would end up with this. So we have px squared plus px minus 2 is equal to minus b, which is minus p plus or minus the square root of p squared minus 4 multiplied by p multiplied by minus 2. Okay, now we are looking for the values of p, and that's divided by 2a. And 2a is, of course, just 2p. Okay, now we're looking for values of p which give us real roots. And you get real roots if you have a positive value inside this square root of the equation. So you would find the range of values for p. So you would say, for this, in this case, p, we would have to say that, which would imply that the square root of p squared minus 4, no, not even the square root, we just have to say, which implies that p squared minus 4 multiplied by p multiplied by minus 2 must equal, or must be greater than 0. So that's basically saying that if this is a positive number, then, then this equation works out. Like, you can actually solve this because that would be a real number. So similarly, if we just write it down like that, you can basically work out the answer from there. So you have p squared minus 4 multiplied by p multiplied by minus 2 gives you greater than 0. So that would end up with p squared minus, plus 2p, plus 8p is greater than 0. And which we can then say that if we take p common, we have p plus 8 is greater than 0. So now we already know that if p is 0, so which would imply that in this case, because it's a quadratic, we can just say p is equal to either 0, or it can also be equal to minus 8. So either way, you would end up with something that's equal to 0. So now we need to work out what happens if we get a positive or a negative, right? So that's what we're going to do. So we're going to say, okay, if we get a 1, so if you put in a 1, what do we get? Do we get something that's greater than 0? Yes. If we put in a minus 1, we're not going to get something that's greater than 0. So which means p has to be greater than 0, which, I mean, it kind of sort of makes sense. Yeah. Yes, definitely. So, which implies p has to be greater than 0. And now similarly, we do the same thing with minus 8. If we say, okay, p has to be, so if we take p to be minus 7, I mean, if we plug that in, so we get minus 7 multiplied by minus 7 plus 8. Minus 7 plus 8 is 1. And you get minus 7 on the outside. So minus 7 multiplied by 1 is minus 7. Minus 7 is not greater than 0. So therefore, p has to be greater. P has to be less than... Yeah, p has to be less than minus 8. Oh, that's where I was getting confused. Because I'm taking a minus 7. Minus 7 is actually less than minus 8. So if p is less than minus 8, you're going to get a negative number, which is not acceptable. But if you get p is greater than 8, so if you get p is minus 9 instead, so we say, okay, minus 9 multiplied by minus 9 plus 8 gives you minus 9 multiplied by minus 1, which gives you 9. 9 is definitely greater than 0. So which means p has to be less than minus 8, because minus 9 is less than minus 8. So that implies that p can be greater than 0. P has to be greater than 0. And it has to be less than minus 8 to give you real roots for this equation. And you can actually plug that in and you'd be able to find the answer. Absolutely, 100%. So bearing that in mind, yeah, you can try to do that. So anyways, we'll say that that's the answer. And yeah, cool. I do believe that's right. Let's just try to see if that's actually right or not. I'm just going to double check the answers. You know, usually most books, they have answers at the back, which usually the person who has sort of written the entire book, he leaves the answers right at the back. So yeah, it's always good to have them handy. Sometimes, you know, the answers can be written wrong, which creates a big hassle for whoever's trying to solve the equations, because they always get confused. They're like, well, I'm not entirely sure how he got that answer, but you know, it's not something as that. Also, yeah, one thing I missed out is also if this was equal to 0, you know, if this was equal to 0, then that would also give you a positive root, because basically the square root of 0 is just 0 or 1, I believe. Square root of 0. 0 to the power of anything is just 0. Yeah. So if you end up with a square root of 0, you just end up 0. Yeah, 100%. No matter how many times you multiply 0 by itself, you're going to get 0. Yeah, definitely. So if I was to... My apologies, just give me a moment. Right, yeah, so basically what I'm trying to say is that this inside equation over here can also be equal to 0 for it to give you like a realistic number that you plug into your calculator and it will give you. So this can also be equal to 0, which means this can also be equal to 0, which means if we're solving for p can also be equal to 0 to give you 0. And p can also be equal to minus 8 to give you 0, which means both of these has to be, you know, p can also be equal to minus 8. It doesn't just have to be less than minus 8 or greater than 0. It can be equal to minus 8 and equal to 0 as well to give you equal roots. Okay, so yeah, that was definitely a little bit confusing, and that's something that you got to watch out for as well. I think it similarly applies in this situation as well. In all the quadratic equations that we solved, in terms of finding sort of inequalities, I think if you have x is being greater than 1, it would also give you, also over here, that would be a plus or minus, because, you know, minus 1 or plus 1. Right. Oh, wow. This is interesting, isn't it? Oh, wow. No. Yeah, no, this is where I messed up. Okay, this is not right. We're going to address that in just a moment. I'll tell you why that's not right. You got to watch out for these squares and square roots and how you deliver them. Because, yeah, you can end up with some stuff that ends up like this. And that's definitely not right. We're going to do that one again. I'm going to explain exactly why that's not right. But yeah, I think with most of the quadratic equations, sometimes if you have a look, yeah, so like for example this one that we saw over here, it can be, yeah, so we ended up with sort of the quadratic equation over here, and if x is equal to 0, you're still going to get something that's 0, but this has to be greater than 0, right? So that's fine. That's fine. If this is not asking it to be equal, then you're fine. But you gotta be careful, because like, you know, that greater than or equal to signs can always be a bit tricky. Okay, now I'm gonna address this second part of the question over here that was 100% wrong, and I'll tell you exactly why in just a second. So this is 11 is less than x squared plus 10. So let's write that down. So 2 repeated correctly, we have 11 is less than x squared minus 10, which I do believe that's what it is. No, x squared plus 10. X squared, so 11 is less than x squared plus 10. Okay, so if you write this down again, I did I said, okay, x squared is greater than, 10 plus x squared is greater than 11. That's perfectly fine. And then I said, then I said x squared is greater than 11 minus 10. That's also fine. And then after that, I said x squared is greater than 1. And then I said x. And then I said x squared, x is greater than 1. Because if you square root 1, you're going to get 1. Well, that's wrong, 100%. And the reason for that is that you can, if you square 1, you can either get a positive or a negative number. And the way that it works is that you get, so if I do square root of 1, you can either get positive or negative 1. Because if you multiply, if you if you get the square of minus 1 is also equal to 1, which is also equal to 1 squared. Okay? So you can get either of those things going on, which is why the way that I did it and I left it just that is definitely wrong. Okay? So if we then say that, if we take it to the other side, this can actually make it a bit more easier for you to understand. So if we take it to the other side and if we say, okay, which implies x squared minus 1 is greater than 0. And then we end up saying x squared plus 1x, or just plus x. Same, difference of squares. We're going to be using difference of squares. So we say plus x minus 1 is greater than 0. And then we end up with x minus 1 plus 1, x minus 1. Right, didn't get that right. My apologies. So it'll be x plus 1, that's the common factor for those two. And then you would get minus 1, and then x plus 1. The minus 1 is a common factor for both of them. And that would be greater than 0. And then we can finally write that as x minus 1 is a common factor, x plus 1 is a common factor between x minus 1. So you get x plus 1 is greater than 0. Right, so once you write that down like that, then you can actually understand why this is actually equal to this and not equal to this, you know? Damn, that was such an intense mistake. I didn't even see that coming. It was just so casual. That's very interesting. Okay, so you need to be careful about the squares and how you square root the numbers. Very, very simple, and you may overlook it at once and be like, oh, wow, it's just definitely just one answer. Well, that's definitely not the case. You need to double check, you need to triple check, you need to find out what the answer is. So in this case, right, x is equal to 1 or minus 1 in this case. Now, all we have to do is find out if x is 0, are we getting something that's greater than 0? So if x is 0, we get 0 minus 1, 0 plus 1, so we get minus 1 multiplied by 1, gives you minus 1. Minus 1 is not greater than 0. So x has to be greater than 1, and x has to be less than minus 1 to give you a positive number. And we can actually double check and find that out if we do that correctly. So if x is greater than 1, we have 2. 2 minus 1 would give you 1, and 2 plus 1 gives you 3. So 3 times 1 gives you greater than 0. So that's why x has to be greater than 1. Now if we have something less than minus 1, so we have minus 2, you plug that in, minus 2 minus 1 gives you minus 3. Minus 3 multiplied by minus 2 plus 1, minus 2 plus 1 gives you, a positive number. Minus 2 plus 1, no, it doesn't. Minus 2 plus 1 gives you minus 1. So you get minus 1 multiplied by minus 3, because minus 2 minus 1 is equal to 3. So minus 3 multiplied by minus 1 gives you minus 3. Sorry, plus 3. Let me just write this down in a different color. Makes it easier. So if I take it as minus 2, so you get minus 2 minus 1 multiplied by minus 2 plus 1 is greater than 0. And then you get minus 3 multiplied by minus 1 is greater than 0. And that is true. You know, so yes, x has to be less than minus 1. Man, that was such a common mistake. Interesting. Okay, so then finally you can say x in the middle. We end up with x is greater than 1 and is less than minus 1. And that, as you can see, is completely different to x being just greater than 1. Which, of course, that's part of the equation, yes. But x can also be, less than minus 1. And you would still get a number that's greater than 0. So therefore, I had only partially solved the equation over here, which is why it was not entirely correct. You know, x could not just be only greater than 1. It could also be less than minus 1. And that's the answer. So yeah, the thing is, you just got to keep an eye out. And people make mistakes as well, you know. I made a mistake. And it's okay. As long as you figure out what you have done wrong and you try to correct it properly. So, like, for example, I was just looking back at my notes, and I just looked at it, and I was like, you know what? That is actually wrong. Let me look at what's the right answer. And I did it. And I basically sort of did the working out, figured it out, and sort of I explained it to myself in my head as well, saying that, okay, you know, that's the right answer. So if you get something wrong, doesn't matter. Don't worry about it. Don't look at it too much. Simple mistakes can be made by anyone. As it's all about sort of practicing and honing your skills and trying to figure out how to not make those mistakes. I mean, even if you were to make a mistake, don't get too hard on yourself, but just figure out how to not make that mistake again and understand why it was a mistake in the first place. Because, I mean, it's always good to question why it was a mistake. So anyways, this has been the quadratic bit of the inequalities. I think doing 5 questions is more than enough, to be entirely honest, just for the workshop sort of thing. But if you were trying to sort of practice, I'd probably recommend doing a bit more of the questions that involve square roots and, you know, trying to find difference of the squares and all of that stuff. But yeah, and again, even if you didn't want to go use the difference of the squares method, you could always use a different method. So if you said, okay, if you said x squared is greater than 1, what you can then do is you can say, which implies x can be either greater than 1. Okay. I think that's literally it. 100%. Yeah, 100%. That's literally exactly it. So, for example, if I was to square x, I could get a positive x. And if I square 1, I'll get a positive 1. So you could get either a plus or minus, right? And if I write it out, I can say, okay, if I say plus x is greater than plus 1, that's fine. That's good. But then I can also say minus x is greater than minus 1, which would then imply x is less than minus 1. No, this is not going in the right direction. 100%. Nope, it's not going in the right direction. That is a little bit weird though, don't you think? I mean, because if you have x squared, and if you square root that, you would also get a plus or minus x. No, because if you were to square root x, you're only going to get a plus x. Huh. I mean, you can say that it's equal to that. I'm trying to figure out a way to do it without completing the square. I mean, when you complete the square, it actually sort of simplifies it and you can actually work it out properly. But, yeah, what if it was just sort of, if you just wrote it like that, then how would you deal with the operator in between? And how would that work? That is an interesting question. Possibly something to ponder on at some point else. Don't want to waste sort of specific precious time trying to worry about that straightforward over here. But I'm possibly thinking it would imply that x is greater than 1, because you didn't have to change any sort of signs. And that would also imply that x is less than minus 1. And that's because you had a negative, so you sort of multiplied it by minus 1. So you change that thing going on over there. Yeah, that is a little bit intriguing that you can't just sort of correlate that directly to being equal to sort of this going into both of these. Is definitely a little bit weird. I don't know. I thought he would be able to do that, but if x is sort of greater than plus or minus 1, x is greater than plus or minus 1. No, because x is less than minus 1. And yeah, x is greater than 1. Right, that is very interesting. Think about that. Yeah, think about that at some point, and wonder why you cannot sort of directly relate that with regards to all of these inequality operators and everything. I mean, if x is greater than plus or minus 1, unless it would be like a negated thing, sort of thing. So if you square rooted, then yeah, but like x wouldn't change. No, because regardless of whether you get, I mean, x squared, if you square root x squared, so if you had x squared and if you square rooted that, you would still get plus or minus x. Square root of anything is plus or minus, essentially. But that's the thing. If you square root, all right, I think you know what. Let's try doing it that way. So let's say square root of that gives you this. So we have x is greater than 1, minus x is greater than 1, minus x is greater than minus 1, minus x is greater than, sorry, x is greater than minus 1. Okay, sounds fair enough. Multiply by minus 1, which would imply x is less than 1. And multiply by minus 1, which would imply x is less than minus 1. So you'd end up with like 4 different scenarios if you square rooted that and you found the inequalities. But because x is greater than 1, and x is also less than 1. But we know we ended up with x is greater than 1 and x is greater than less than minus 1. So we got x is less than minus 1 over here if we did that. And we got x is greater than 1 if we did that. That's weird. That is so weird. So basically, don't do it this way. Just do it the completing the square way if you end up with something like this. That's an interesting question, you know. That's probably like, that gives you some time to think about why it wouldn't be one like both of those. And then possibly you can just sort of work it out like, you know, has to be equal to 0 or something. I don't know. Yeah, I don't know. You probably like, yeah, probably work out something like that. Maybe. I don't know. It's weird because this would not exist. And it's weird because this would definitely exist. I mean, if we take a look at this one and we say multiply them both by minus 1, so we get x is greater than 1, and we already know that. But if we swap things around, and if we say, okay, minus x minus 1 is greater than 1, it's greater than 0, sorry. And then you multiply it, so you would end up with you'd end up with x plus 1 is less than 0. And then you would end up with x is less than minus 1, which is what we ended up there. That is super duper weird. But you can also end up with that. Well, this is confusing. Doing a workshop. Trying to show how confusing math can be when you're trying to work it out on your own. No, but the point I'm trying to make is that, you know, yeah, you're always going to get some, like, issues like this. But what you need to do is you don't need to worry about how to sort of work with operators and what would rearranging get you. Because you can rearrange in many, 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 many different ways. Okay? You just have to worry about which way you rearrange it, and that gives you the right answer. And usually that helps if you're sort of proving you're working out. Yeah. But ideally, you know, what I'm thinking of, like, I'm looking at this, I don't think that would actually be true. Because, look, if I multiply the whole thing by minus 1, see, if you just multiply minus 1, multiply by minus 1, you get x is greater than, no, x is less than 1. Which of course is not possible because x is greater than 1. Let's see what the answers have to say. Let's see which one that is to begin with. Alright. That is most definitely a difficult question. It's a dodgy question, if anything. Okay, so this says x is less than minus 1, which is that one. And it also says x is greater than 1, which is that one. So we got it right using the sort of complete the square method. But what I'm confused about is... Oh, okay. Yeah, because I said minus x squared will give you minus 1 squared. Similarly. I mean, there are possibilities. I don't know why it wouldn't be that. But then what really gets me is that you can sort of rearrange that and it will give you 2 separate answers. That is honestly the weirdest thing I've ever seen. Because like, if I multiply the whole thing by minus 1, then I get x is less than 1. But then if I do it this way, so if I take the minus 1 that side, multiply it, you get greater than 1, take it towards the other side, yep, getting that. Super weird, am I right? Super duper weird. I want to see, what if you had like x squared minus 4 is less than 0? Sorry, greater than 0, yeah. So according to this, what we've learned, it should basically be x is sort of greater than minus 2 and less than 2. Yes, so x has to be less than minus 1. Sorry, my apologies. It's the other way around. Minus 2, greater than 2. But if I was to sort of work it out, and if I said, okay, cool, let me try to work it out, I would end up with x squared is greater than 4, x is greater than plus or minus 4, 2, sorry, plus or minus 2, and that basically splits up into many different realms. Yeah, so for me that actually does split up into many different realms. So for me that goes into sort of x is greater than 2, minus x is greater than 2, minus x is greater than minus 2, x is greater than minus 2. So in my opinion, that's the many different combinations that you can have, essentially. But 2 of these combinations are not going to be right, because you can't have x is greater than 2 and x is also greater than, minus x is also greater than 2. Can't have that. So if x is greater than 2, let me try actually seeing if that actually works. So if I have x is greater than 2, then if I have x is greater than 2, then I have minus x is greater than 2. They would fall within the same realm. Okay, you know what? I'm definitely just getting carried away. What I'm going to do is I'm going to take a break, and we're going to leave this question here as it is. Any of you that do find an answer in the future as to why it's not these bottom half of the equations, do let me know. I do believe that there's 4 different possibilities that could be formed, and then of course 2 different possibilities every time that you work with minuses on both sides. You can either sort of minus both sides, and then after you get sort of it's still greater than 0, or you can just literally multiply, switch up the equation terms, and that'll give you the same answer. Super weird. Cool, so we're going to leave it as it is. For any of you that do find an answer to this page of monstrosity that has confused me, do give me a shout. That'd be great. Thank you. Okay, so we'll move on, and I'm going to meet you guys back in 10 minutes. So that's roughly at precisely 20. Roughly. Precisely. Roughly. So roughly at 20. 2000. I will see you guys back. Take a break, go stretch out your legs, probably drink something. You like some water or something. Whatever works best for you. Hello everyone, I do apologize. I've been trying to feed myself just a little bit. I went out and got myself a drink, a nice little smoothie. I know I said 2000 and this session is definitely not the best one to be to be classified behind my services and my exemplary performance in all different aspects. But no, yeah, so this is the kind of stuff that we're gonna do. I hope you guys had fun. It's a good, nice little thing for you guys to sort of, have a look at and try to figure out yourself in the future. Or even now, anyone that comes up with the answer, just give me a shout. It's always good to have a discussion as well. Not sure why some things are just the way that they are. But as long as you find most of the right answers and you're like, you know, I can justify specific answers. So you can, so for example, in this case, I can justify the answers for, you know, the first two sections, for the first two, but I can't justify the answers for the other two, you know. I can't justify the answers for the other two. So we'll probably just leave it as it is in that case. Yeah. Essentially. Okay, so moving on. We're going to try and do some randomized exercises, and then we're going to move on to trying to divide fractions just as they are. So I believe if I take a look at the schedule based on what is there, we're going to be doing division, and we're going to be doing some algebraic fractions as well. Or maybe you just ought to sort of jump into those questions and stuff as well again. Maybe. Let's do a couple more of these inequalities stuff, and then yeah, we'll move on from there onwards. So this was the inequality for quadratics. We repeated that. We found that out. It was wrong, and yeah, we're moving on now. Yeah, let's just move on. We're gonna do some algebraic division. Cool. So the way that this is gonna work is, yeah, let's just start off. So we're gonna start by divide these algebraic fractions. Okay. So the first one that we have is 4x to the 4, 5x squared, sorry, plus 5x squared minus 7x divided by x. 7x divided by x. So again, what we can do is we can take out x as a common factor. We say 4x cubed plus 5x minus 7. And now this is all divided by x, and that just sort of cancels out, so we end up with which would equal 4x cubed. And remember, this is not equating anything, so it's not an equation, it's just an expression. So 4x, right, which reminds me that it doesn't imply, is just equal to 4x cubed plus 5x minus 7. And that's the answer over there. Let's try simplifying something else as well, again. Let's try having something a little bit more complicated. So we have number 2. You write minus x to the power of 8 plus 9x to the power of 4. And we have plus 6. And it's asking us to sort of simplify this whole thing. So let's try and do that. And that's sort of divided by, my apologies, minus 2x. Okay, now what we can see over here is x to the 8 is basically, we can write this as minus x to the 4 whole to the 2, or actually, yeah, it'll be minus x to the 8, x to the 4 whole squared plus 9x to the 4 plus 6. And that's divided by minus 2x. So what we want to do over here is we want to say, what do we want to say, guys? What do we want to say? So that's equal to that. So we want to say, well, you know, the minus and the minus can sort of, if you multiply the top bit by minus and the bottom bit by minus 1, we'll end up with something a bit more, we're going to be taking a step in the good direction. And also if we replace, if x to the 4 is equal to y, let's just say that, okay, we would imply that y, and remember we're multiplying the top bit by -1 and the bottom bit by -1. So y squared minus 9y minus 6 is divided by 2x. Okay, and if we take a closer look at this, we can see that x is equal to the fourth root, so the fourth root of y. I don't want to write that down because that's just going to confuse everyone. So we're just going to leave that as 2x. But what we want to do is we want to solve this quadratic equation first, and then we see where we go from there onwards. Possibly, maybe, I don't know. I'm just trying to take the steps and trying to see if it's going in the right direction. So we're trying to solve the quadratic equation at the top. Something that multiplies to give us -6 and adds to give us -9. What would that be? Don't think that would actually be anything. Something that multiplies to give you -6 and adds to give you -9. That'd be, was it 7? No, can't get that. 8? No. 8.5? No. 9? 9 multiplied by a third? No. I don't know. To be honest, I don't think that's possibly the right way, the one that I picked. But yeah, let's try to retrace our steps. So I don't think that's the right way to do. But let's try to take that in a different direction. So you have -x to the 8. We have plus 9 x to the 4 and plus 6 divided by -2x, which will equal, and then of course we multiply top and bottom by minus. We end up with x to the 8 minus 9 x to the 4 plus 6. Sorry, minus 6 divided by 2x. Want to do the same thing, so I'm going to divide individual terms by themselves, and it would end up with right, sorry, yeah, it would end up with x to the 8 divided by 2x minus 9x to the 4 divided by 2x minus 6 divided by 2x. So that would give you x to the 7 divided by 2 minus 9x to the 3 divided by 2 minus 3 divided by x. Suppose that could be called simplification. I probably wouldn't call that a simplification, but yeah, I mean, if you had to sort of expand all the terms, then yeah, probably just end up with that. But now if you actually had to divide the equation and sort of, what was the topic? Was it supposed to divide the whole thing? Yeah, you kind of said divide the algebraic fractions. So what we're going to do is we're going to try to divide the whole thing as well. But yeah, technically, if you did divide the whole thing, you'd probably just end up with this. What is shown on the page over here. Nothing simpler. Okay, let's try a different manner. Let's do a different question, sorry. 3. Let's see, 3x squared minus 7x plus 2 divided by 3x minus 1 and x plus 2. So we're going to try and sort of factorize the top half of the equation to see if we can get any common terms. I probably think we'll probably get like a 3x minus 1. Hopefully, maybe it will be 3x plus 1, x plus 2. I don't know. Let's find out. So 3x, something that multiplies to give me 6 and adds to give me minus 7. So we have 3x squared minus 6x minus x plus 2 divided by 3x minus 1 x plus 2. And now what you can do is you can basically sort of go off into a trans. So I can just say this is numerator factorization. Remember, after you're done with that, you basically have to substitute in the values into the original equation, which is this. That's the original equation. So we say that's that. So we say 3x. It takes out as a common, and we have x minus 2 inside. And we take out a minus 1 as a common, and x minus 2 again inside. And that would equal 3x minus 1 on the side with x minus 2 as a common factor, and that'll be that. Cool. So we substitute that into the original, which would then imply 3x minus 1 x minus 2 divided by 3x minus 1 x plus 2. And you just sort of basically cancel them out, which would then give you x minus 2 x plus 2. Boom. And I don't think that can actually get any more simpler as to what it is right now. So we'll just leave it like that, as it is. And remember, because it's not in a third form, you don't have to worry about it. Like, you don't have to sort of try to make it. There's nothing to rationalize because it's already in a rational format. Let's do another one of those. This time I'm going to do a little bit more tricky one. X squared plus x minus 12 divided by x squared minus 9x plus 18. I'm just going to split this up into like an A and B format, or like an N and D format. Numerator math is x squared plus x minus 12. Something that multiplies to give me minus 12 adds to give me x is probably 4 and 3. So we have x squared plus 4x minus 3x minus 12, which is then equal to x plus 4. And you have minus 3, x plus 4, which then equals x plus 4, sorry, x minus 3 with a x plus 4 common. And denominator math, we end up with x squared minus 9x plus 18, which would be equal to, not implied, so equal to something that multiplies to give me 18 adds to give me minus 9. It's probably minus 3 and minus 6. X squared minus 6x minus 3x plus 18. And we end up with x as a common between x minus 6 and a minus 3 as a common between x minus 6. And that would equal to x minus 3 with a minus x minus 6 as a common. Substitute them in. Okay, and that would give you x minus 3 at the top, x plus 4 at the top, divided by x minus 3 at the bottom, and x minus 6 at the bottom. Minus 2 cancels out, so you end up with x plus 4 at the top. divided by x minus 6 at the bottom. And that's the final answers. So that was, of course, for the previous question. This one was for that question. I think this one you can just leave it as it is. I know it's not the most neatest division, but that's essentially how you divide fractions. You take them one by one and see where it goes. Okay, we're gonna try and do one more of this, and then we'll move on to division by a polynomial. So essentially what we've been doing is also division by polynomial, but we're going to do sort of long division method, which is what they call it. And we're going to run through sort of factor theorem to check if something is indeed divisible. And we're also going to check... Yeah, no, I think that's pretty much it. Yeah, just got to check if something is actually indeed divisible. And yeah. Okay, so number 5, let's do another question for that. You guys are going to probably laugh at this one, but x plus 3 squared, x plus 3. What do you guys get? X plus 3. For those of you that didn't understand that one, you probably understand the next question. Okay, so that's that one done. And we're going to go into long division. Do some more questions for those, for workshops, bits. You know, I really should probably split these workshops into something that's a bit more reasonable, frankly speaking. But now that I've actually realized how this is going to work, I'm probably going to start creating more and more events rather than having just one long workshop, because this is literally all over the place. I mean, we're rushing through so many different topics. Frankly speaking, we're rushing through so many different topics, and you know, I think it's better if I sort of hold one workshop for every single topic that is there available. So you know what? I'm going to carry on doing this between Tuesdays and Thursdays, and I'm going to try and see how this is sort of panning out. And yeah, we'll see where to take it from there onwards. But I'm not very, I'm not entirely very confident that this would result in anything good, because we're just sort of solving questions out of the blue, and doesn't have any structure to it. That does seem a little bit weird to say. I mean, because we are sort of moving one step at a time, but I believe these steps have been taken so quickly, it's difficult to follow through. So what I'm going to do is I'm going to rethink, I'm going to reassess how all of these workshops take place. And I'm going to come back, and hopefully next week we're going to start doing some serious questions in a serious manner. Okay, so I'm going to do a couple of long division questions since we already sort of mentioned it. I mean, why not? We're already here. Let's do it. So let's see if we can do x cubed plus 6x squared plus 8x plus 3. And you got to divide that by x plus 1. So the way that you do it is you say x plus 1 is on one side, and you add in the division column, where you would write in your big polynomial, x cubed, or your numerator essentially, plus 6x squared plus 8x plus 3. And you would take it one by one. So you would do x plus 1. So if you, how many times would you multiply x plus 1 to sort of cancel out x plus 3? You would get times x squared. Am I right? Yeah. So if you multiply that, if you multiply this whole term by x squared, you would end up with x cubed plus x squared. And now you want to subtract both of them. So that cancels out, of course, and you end up with 6x over there. Well, you don't end up with 6, sorry, my apologies. You end up with, because you're subtracting the thing, isn't it? Yeah. So you end up with 6 minus x squared, so it will be 5x squared plus 8x. And you're only keeping 2 terms valid over here. And you want to multiply that by 5x to give you the first term, which is going to be 5x squared. So 5x multiplied by 5x by x is 5x squared. And 5x multiplied by 1 gives you plus 5x. And you want to subtract the whole thing by the top one. So you would end up with 3x plus 3. And if you multiply x plus 1 by 3, you would end up with 3x plus 3. And you subtract both of them, and it ends up with 0. Now what that's basically saying is if you multiply x plus 1 these many times, you would get this. That's exactly what it's saying. So which implies x cubed plus 6x squared plus 8x plus 3 divided by x plus 1 is equal to x squared plus 5x plus 3. And that's how you do long division. Let's try another one, because I do believe there's enough space. Let's do another one, number 2. Now these questions can actually get rather lengthy. So you want to try to space yourself out, give yourself a lot of space on any paper, whichever paper you're attempting it from. Let's try doing, which one are we going to be doing? Which one are we doing? That's a really big one, isn't it? Well, goes into like 6 and stuff, to this power of 6. Quite a heavy one. Alright, let's try doing a negative one. Are there any negatives ones? Yeah, so we have minus 2. I'm just going to write it down properly now. So we have to divide the following term by x minus 4. So we're dividing it by this term. And the term to be divided, so the numerator, is minus 2x cubed plus 5x squared plus 17x minus 20. Okay, so once again, we want to make the first term equivalent to this, because that's the easiest way to do it. So we get minus 2x squared multiplied by x gives you minus 2x cubed. And you get minus 2 multiplied by minus 4 gives you plus 8x squared. And we want to subtract the whole thing by the top one. So we end up with a minus 3x squared. Bring down that one, plus 17x. And what was this? So 3a squared. So if we try to multiply that, we have to get, so divide this by the first term. Divide this by the first term, gives you minus 3x. So you would end up with minus 3x squared. Why? Because minus 3x multiplied by x, minus 3x squared. Plus 3 times 4, 12. 12x. And you go subtract the whole thing. So that would give you 5x minus 20. Divide 5x by x gives you plus 5, 5x, and 5 times minus 4 is minus 20. And when you have to subtract the whole thing, you end up with 0. So that would imply that minus 2x cubed plus 5x squared plus 17x minus 20 divided by x minus 4 is equal to minus 2x squared minus 3x plus 5. That's the answer. Now what you notice is that whenever you're dividing like a cubic equation with a singular sort of a linear equation, you're ending up with like a square. So, you know, it's just sort of whichever power of polynomial you divide with the, you know, whichever other power of polynomial, it still follows the rule of indices. So if you take a close look at that, we got x to the 1 at the bottom, so it's x to the minus 1, and x to the 3 at the top. So that does end up with x to the 2. And you see the similar pattern being followed in this basic sort of thing that we did over here. We have x to the minus 1 over here, x to the 8 at the top, and you end up with the highest term being x to the 7, x to the 3, and then x to the minus 1, because that one doesn't really have any term. So it's not divisible. There's a remainder at the end, essentially. Now if you were to try and devise this specific equation using long division, it probably goes something like this. Let's see how it could go. Yeah, let's write that down. So we have test. So we're going to be dividing 2x. We're going to be dividing the following term by 2x. And we have x to the power of 8 minus 9x minus 6. X to the power of 4. My apologies. Right. So now the thing about this is that you would have to use all of the different terms. So you have x to the 8 plus 0 multiplied by x to the 7 plus 0 multiplied by x to the 6 plus 0 multiplied by x to the 5 plus, no, that's not a plus. So now that would be a minus 9 to the x4. And that's because, well, if you sort of cancel out the negative terms, you sort of that term's minus, that term's minus. And you would get plus 0 multiplied by x to the cubed, plus 0 multiplied by x to the squared, plus 0x, and minus 6, finally. There you go. So now we're trying to sort of long divide this whole big equation. As you can see, complexities increase when you are trying to sort of long divide, use long division for sort of increased complex equations. Anyways, we're gonna attempt this, and we're gonna see how it sort of relates to the term that we just did, just by sort of simplifying this equation. We get something similar, or do we not? What does it look like? Let's see. So we're gonna divide this by 2x, and we end up with 0.5 x to the 7. Okay, and that's what we end up in the first place as well. So you get 0.5 x to the 7. x to the 7, okay, and that ends up with x to the 8, because it'd be a half multiplied by 2x, x to the 8, and So I think in this case there's not actually any use for using polynomial division. Sorry, my apologies. So like I said, in this case, there's not actually any use for using polynomial division because this is just a singular x expression. It doesn't have any addition or anything else. Because this is technically 2x plus 0. So if I add a plus 0 over there, and if I multiply this by the second term, I'll just get a 0. So while this is, if I negate both of these, I'll just get a 0. And then, of course, that's going to be 0, 0, 0. So, yeah, 0, 0. And then I end up with a minus 9, x to the 4. So I end up with a plus 0, plus 0, plus 0. And then you end up with a minus 9x4. So minus 9x4, if you divide that by 2x, you'd end up with minus 4.5. So minus 4.5 is roughly 9 divided by 2. Yeah. So literally 9 divided by 2 x cubed. 9 divided by 2 x cubed. Get that. And that would give you, and of course it has to be a minus, because sort of multiply, if you multiply minus 9x by that, you get a 9x to the 4. Yeah, and then you get a 0. That's also 0. That's also 0. That is also 0. And you end up with a minus 6 right at the end. And now something that would divide by minus 6 to give you 2x would be minus 3 x to the minus 1. Yeah. Now if I multiply this by this, then I would end up with minus 6. And that'd give me 0. So technically this is the easiest way. Well, this, using this method isn't, but this method definitely gives you the exact same answer, as you can see. So it's the most precise and easy way to conduct this kind of a division. Okay, let's wrap this one up because, yeah, it's getting a little bit confusing. But I hope I try to clarify that as much as I could. Long division. Alright, let's do another one. Let's take a more complicated one. Let's do 6 to the 5. We're going to be dividing this term, 6 to the 5, by x minus 3. Is there any better ones to divide by? Probably do have a better one. They're just not so showing it up at the moment. No. Let's see. Divide by that, divide by that, divide by that. Come on, divide a polynomial by a polynomial. Why wouldn't it let me do that? Yeah, they usually sort of only tell you to sort of divide by a standard number. But what I'm going to try and do is I'm going to try and do a division. Because sometimes you get like a remainder as well, you get a remainder when you try to divide something. So let's try getting a remainder first, and then after that I'll move on to the next step. Number 2, number 3, right? Number 3. Okay, so we do number 3. Let's say find the remainder. Okay, cool. So we're dividing this entire term, which I'm going to write next, by this term, x minus 6. and we have to divide this term by that. Apologies. 3x cubed minus 20x squared plus 10x plus 5. Okay? And we're supposed to find the remainder. Now, as you can see, possibly, most likely, we're most likely going to get a remainder because it's difficult to get minus 6 to be equal to plus 5. That's literally the only reason. But let's see how it works out. So, divide 3x to the cubed by x, and that gives you 3x squared. 3x cubed, 3x squared multiplied by minus 6 gives you a minus 18x squared. And then you got to subtract this whole thing by the top one, by the top two terms. You end up with a minus 2x squared. And just to confirm if I've done that right, 3 multiplied by 6 is 18, and you get negative minus 18. Minus 20 minus minus 18 gives you minus 2x squared. Bring that term down, plus 10x. And yeah, because you have only sort of two terms, bring the term down. 2x, let's see. Divide 2x squared by x. Minus 2x squared by x gives you minus 2x. And yeah, you end up with a minus 2x squared. Plus, is it plus? Yeah, it will be plus. So you get minus multiplied by minus plus. And 6 times 2 is 12. 12x. Supposed to negate all of these terms. I don't know why did I do that. It's supposed to negate all of these terms, so you're basically sort of subtracting this by that. You end with a minus 2x plus 5. Now to get a minus 2x, you just have to multiply by a minus 2. So minus 2 multiplied by x gives you a minus 2x. And you end up with plus 12. So the remainder over here is actually because you sort of negate all of this. So you get 5 minus 12, which is minus 8. Nope, 7. Yep. So you get minus 7. That's the remainder. So what that basically tells you is that if you didn't have a plus 5 at the end, instead, you had a 12. Because you had 7 plus 5 gives you 12. So you would end up with, if you had a 12 at the end, then you would end up with nothing. So the remainder is minus 7. Does that make sense? So if that was equal to 7, yes, no. If that was equal to minus 7, then this would be divisible by x minus 6. Like fully. Yeah. So anyways, you would write it as this. Where would you have yes, where you would have 3x cubed minus 20x squared plus 10x plus 5 divided by x minus 6 is equal to, and you would have 3x squared minus 2x minus 2 plus minus 7 over x to the minus 6. I believe that's exactly how you would write it. Because that'd be remaining. Yeah. Yeah, as far as I'm aware. So that's like the whole number added a fraction. Yeah. That's like a mixed fraction, essentially. Right, so that'd be the answer. Okay, now what I'm about to attempt is something quite complicated, and before I do that, I probably want to try and get another question in, try to see if we can do that. So we're going to try it in simplifying this equation. Quite simple. We're going to divide the following term by the term I'm about to write now. So we have x minus 2 as the denominator, and the actual term is 3x cubed minus 0x squared minus 8x minus 8. So you have that. It's a dividing term. So divide 3x cubed by the first term in the linear equation. You end up with 3x squared. So you end up with 3x squared. Multiply that by that. You end up with minus 6x squared. Minus the whole thing. You end up with a plus 6x squared. Minus 8x. Plus 6x squared divided by x. 6x. 6x squared. Minus 6 multiplied by 2, 12. X, whole thing negates. You end up with a plus 4x minus 8, and you want to do a plus 4, so you plus 4x minus 8, and if you subtract the whole thing, you end up with a 0. So that would imply 3x cubed minus 8x minus 8 divided by x minus 2 is equal to 3x squared plus 6x plus 4. And that's that. So that was good practice. We've done quite a few long division methods, and yeah, we tried to sort of justify doing long division for normals as well. What we're going to do now is going to be a little bit more complicated, and it will sort of give you the idea behind long division as well. So let's try and attempt that. What we're going to do is we're going to try and divide a polynomial by a polynomial, is what they say, yeah. So the way that it works is, if I say, let's do a basic one. You know, let's go back to the equations and actually see something that's reasonable, and then I'll work backwards from there. Yeah, now see, that's the kind of thing that I should have done before. Okay, I'm going to try and make up a question now, see if this works. We'll just call it 5, anyways. Okay, so what we're going to do is we're going to divide the following term. Let's make it simple. So we have x squared minus 10x plus, okay, let's find two sort of addition things. 16. Okay. And now we're going to divide that by 12x cubed. Not cubed. Let's make it a bit bigger. 12x to the 6 minus 2x to the 5 plus 0 x to the 4 minus 7x to the 3 plus 2x squared minus 10x plus 16. Let's just do that. Quite simple enough. Okay. Right, so let's begin. So we divide the first term of this polynomial, the longer one, the numerator, by the denominator. And that would be sort of 12x to the 6 divided by x squared. And that would give me 12x to the 4. So if I multiply 12x to the 4 multiplied by x squared, will give me 12x to the 6. Okay, multiply that by the second term, 12 by 10x would give me minus 120. That's a big term. I should not have done 10. Anyways, minus 120 x to the 5. Absolutely. And we multiply that by that. So 12 by 16 is, whoa, big number, isn't it? 12 multiplied by 16 is 160 plus 24. 184. So plus 184 x to the 4. Subtract this whole term. So we end up with that. That's of course 0. We end up with a plus 138. Oh, wow. 118, sorry, my apologies. 118x to the 5. Plus, no, sorry, negative 184x to the 4. Big numbers coming up. So, again now, because this is, we're dividing this by a sort of a 3-termed polynomial, we have to bring down 3 terms. So you get a minus 7x cubed at the bottom as well. And what we're trying to do is we're trying to find, you know what, I just want to make sure I'm getting the right numbers. So I'm just going to use a calculator as well. So if I do 12 times 16, yep, it's 192. 12 times 16 is 192. Oh, because it's 32, right? No, 124, right? Right, wow. Surprisingly, it actually saved me. 12 times 16 is 192, not 184. So that's wrong. That's wrong. It's 192. 192. Cool. And just as long as I got the other one right as well. Yep, that's definitely 120. So minus 2 plus 120 is 118. Okay? Cool. Now what we got to do is we got to find the next term. So we got to divide this by this. And that would end up with a plus 118. Don't call that number. It's actually a premium number. 118x to the 3. Okay, yeah. And you multiply that by that, you end up with plus 118x to the 5. Multiply by 118 by 10, you end up with minus 1180x to the 4. Now, those numbers just keep getting bigger, isn't it? Good lord. All right. And a minus at the end. You know, with a plus actually. A plus 118 times 16. Why did I make it 16? God damn it. 18888. 1888 x cubed. Yeah, this is random. It's good for the last question. Literally, wow. What am I doing? Alright. So we do the additions and blah blah blah, whatever. That cancels out. 190 minus 192 plus 1180 is 1180 minus 192 is 988, as you can see. Did I get that right? 1180 minus 192, yeah, is 988. So 988x to the 4. Oh, there's many more terms to go. It's nice. Cool. 988x to the 4 plus. Right, now this is interesting, isn't it? Minus 7 minus 18888. So 18888, well, no, 1888 minus 7. Well, it's actually plus 7. And the whole thing is negated. It's 1895. X cubed. This is just turning into a ridiculous question. 2x squared. That brings it down. Remember, we've got like 2 more terms to go. So, hold on. Don't faint just yet. You know what I'm going to do? I'm going to try and sort of reduce the size of this. Lucky I have a pencil that actually allows me to do that. Seriously, very lucky that I have a pencil that allows me to do that. I did not know where this was going. Okay, 2x squared brings down. Right, so now we got to find 988x to the 4 divided by x squared will give you plus 988x squared. Multiply that by that. So multiply 988x squared by all of this, and you would end up with 988x to the 4. You would end up with a minus 9880. This thing is literally just increasing in size. God damn. X to the cubed. And what would that be? What would that be? Plus right, 988 times 16. $15,808. Should have expected no less, no more. And that's an addition. 988 times 16. Ah, wow. Living to regret mathematics already. Just kidding, I'm not regretting it. Love mathematics. Alright. So you'd end up with, of course, that would just cancel out because you're just negating the terms you're trying to take away. You would end up with a really, really big negative number over here. FYI. Actually, positive number, mind you. So you get 9880 added Is that added? Yes. Yes, it isn't. No, it isn't. It's a negative. Yeah, I was wondering why that was an addition. That was supposed to be negative. Yeah, because you have added, and that's a negative. So 188 minus... yeah, no, that's good. That's good, that's good. Plus 2, that's also good. I was going to make sure, because like when you're doing these long sort of division terms, you got to make sure that your signs are all right. If you get your signs wrong, you get the operators wrong, it turns into a mess. And you got to start the whole thing all over again. Anyways, 9880 plus 1895 is equal to 11775. So you end up with a negative 11775. No, that's wrong. That's wrong. Supposed to add those. Yeah, you're supposed to get, because that would be a positive. It's minus 10 is positive. So you end up with a 9880 take away 1895. So it was 7985. So you end up with a 7985 x cubed plus, and now that would be sort of a negative big term. Right. So minus 15,808 take away 2. Add 2, sorry. So that would be a minus 15,806 x squared. Excuse me. 10 goes down again, and you get a minus 10x over there. Let's see what this turns into, isn't it? Should be interesting. These numbers escalated really quickly, though. You're looking at this like, what the heck? All right, so dividing that by that, we end up with plus 7985x. Yes. And then you got to multiply that by the whole thing. Impressive. Well, not really, but quite impressive indeed. Depressive indeed. So we get 7985x cubed, first term, minus 7985x squared, second term, plus 7985 multiplied by 16. 127,760 x. $127,760x right at the end. Seems like a small enough number to me. Okay. So satisfied with that. We get that obviously cancels out. And we have to add 79850 with 79850 plus. No, because that would be a plus. 79850. 79850 take away 15806. 15806 gives you 64044 plus minus 12770 770 epic. Last term comes down, plus 16. And that would allow us, alright, so this is an x squared. My apologies, forgetting to put in the polynomials already. Right, so now this is the final thing that you can do, is what you can do is you basically divide that by that. And that you would end up with a plus 64044. So that's the whole, that's the max you can whole numberly divide it by. And then you're going to end up with a remainder. Whatever remainder ends up over here is what you would end up with. I'm just going to unlock this because we need to see more. Okay, so you would end up with a 64044x squared. And then you would be with a minus 64040 x, and you would end up with a plus 64044 multiplied by 16. You end up with a million. You've gone into 7 digits now. You guys should be happy. 1024704. Okay, and what we got to do is we've got to negate the whole thing. So that obviously cancels out. And then you're left with 640440. 640440. Take away 1277770. 770. And you end up with a 512670 x. 512670x, and a negative term of 1024 704 minus 16 gives you 1024688. Okay, so that's what you end up with. So what you can write this as is, like again, I said that before, you can write this as, so if I was to write this, I can write 12x to the 6 minus 2x to the 5 plus, no, minus 7x cubed plus 2x squared minus 10x plus 16 divided by x squared minus 10x plus 16 is equal to would be equal to, sorry, I'm sorry, I took a couple of minutes off. Just I was thinking, I was reading some aspects of the book. But yeah, you would end up with, it's best off writing that on a new line. You would end up with 12x to the 4 plus 118x to the 3 plus 988x to the 2. And you have 7985x plus 7985x plus 64044. And all of that would be added five one two 670x minus 24688. Divided by the original polynomial, which is x squared minus 10x plus 16. So obviously this is the remainder. That's the remainder, sorry. Yep. And that's the whole number that can be divided by this. Okay, so that's what we end up with. Now to double check this equation, I know there's no possible way that, you know, there was no possible way, but nowadays people, they have sort of internet where you can actually sort of, because everyone's dealing with AI and stuff. So what we're going to do is we're going to try and recreate this equation and see if I can actually do that properly, because it's an interesting answer. I want to see what I get. Okay, so what we're going to do is we're going to try and type this into the magic box, and we see what we end up with. Okay, so we have 12x to the 6 minus 2x to the 5 minus 2x to the 5 minus 7x to the cubed plus 2x squared minus 10x plus 16. Did you get that? Plus 2x squared minus 10x plus 16 divided by x squared minus 10x plus 16. So we have 12x to the 6 minus 2x to the 5 minus 7x cubed plus 2x squared minus 10x plus 16 divided by x squared minus 10x plus 16. Okay, let's find the results. I'm not actively too surprised that it's not showing you the answers, but I'm 100% sure that I did it the right way. Another way to sort of try and do that is to say, is that equal to anything? No, it doesn't tell you anything. Yeah, what a shame. But anyways, yeah. I mean, this sort of a thing probably won't be sort of useful in terms of when you try to get things done. But let's try and see if we can actually try to recreate something. So what I'll do next time is I'm going to try and work out a proper long division as 1, because this was just random numbers. And obviously, while I did all of the calculations perfectly and precisely, this one, there's no, because I don't have anyone else to sort of double check this problem and tell me whether it's right or wrong. So you guys are more than free to have a look at it and tell me whether it's right or wrong. Alternatively, what I'm going to do is I'm going to look at some other questions and I'm going to try to see if I can get the right answer for that. But yes, this is one of the other ways to long divide. And it may seem a little bit too extreme, but yeah, that's another way to do it. Okay, it's been more than 3 hours now. We've been working, we've went through so many different topics, so many different ideas, so many different theories. But what I'm going to try and do next time is I will just... Right, the camera's been flipped now. Okay, no, but the next time that I'm going to do is what I'm going to do. Come on, there you go. Good. So I'm working a bit slow because, again, sort of nighttime. But anyways, the next time what I'm going to try to do is I'm going to try and figure out an easier way to get the long division. We're then going to move on to doing partial fractions within the actual... the realm of algebraic equations and doing basic mathematics. And from there onwards, we'll go on to trigonometry, if not coordinate geometry. So keep an eye out for that. And yeah, keep an eye out for the lecture series as well. The lecture series is really important, and it can be very beneficial for people who are sort of trying to grasp the understanding behind all basic mathematics. So try to have a look at those, and I'll catch up with you guys later. And I think most of these workshop series that I've been sort of performing and trying to do all of these questions, they're all going to go off for free, so don't bother sort of buying a ticket or anything. And that's the last time I'll sort of speak of it anyways. But yeah, there's going to be a change in structure as well, hopefully, to make it a bit more easy and for people to actually follow, and for me to even follow as well. Because at the moment it's just sort of me grabbing books and everything, be like, oh, where's the next question? But I don't want to keep doing that. I want to make sure that it's pretty structured. essentially. So that's what's going to happen next time. Thank you so much, everyone, for joining in today. I really do hope you guys have an extremely lovely day. And until next time, bye. Take care.